Welcome back to our virtual online labs. Today we're going to be doing lab number 4, and it's the determination of a concentration of solution using Beer's law. Now, I've had students be concerned about that in the past, but Beer's law doesn't have anything at all to do with alcohol or the beverage beer. It instead states that the concentration of a chemical solution is directly proportional to its absorption of light. So what that means is that if you take a solution with pigment, the more concentrated it is, the more light it will absorb. And you can use that to determine an unknown based on concentration. Okay, so now let's take a look here. Right here you can see I have what's called a stock solution. And a stock solution means it's the solution that we are beginning with. And this one is going to be number 5, it's all stock. Okay, and then we have on this side, we have water. And then we're going to be doing a series of dilutions. So this is getting a little ahead of us. We're going to be doing a lot of dilution chemistry in chapter 4, but today is a good day to see it before we learn it. And we're going to have solutions that match. Okay, if I come over here and look at the lab, we have concentration. And to be really honest, 0, 2, 4, 6, 8, 10, these aren't real concentrations, and the capital M afterwards means molar, which you'll learn about later. But again, these aren't real concentrations, but the absorbance will be real, and they'll be able to look at it. So what we're doing is we're calling this stock solution 10 molar, just for the sake of argument, and then we have 0 molar here with our water because it has nothing in it, and then we're going to make this series of dilutions. Okay, so let's begin, before we start doing anything else, let's begin with these dilutions. Now, I have what's here called a disposable pipette, and I have marked the 1 milliliter line upon it here. Okay, and so now what I'm going to do is I'm going to start with the water. You can see that I need 4 mils, 3 mils, 2 mils, and 1 milliliter of water in there. So I'll start here. And we'll put in 1, 2, 3, and 4. Okay. Now in our second container, we're going to put in 3, 1, 2, 3. All right, and you'll notice in the lab, it says we're going to do a series of dilutions, and I actually want you to explain what we're doing here because dilution chemistry is very important. All right, and now in solution 3, we're going to put in 2 milliliters. 1, 2. And then in solution 4, we will put in just 1. All right, and now I'm going to come over to my stock solution and we'll make our solutions here. Now, this is an interesting thing. So what I would do in order to rinse my pipette is you put the pipette in and you bring up liquid a couple of times. And that's how to make sure that what you have is pretty much uniform. I'm just mixing it to make sure that it's really well mixed. And now I'm going to go, here I have solution number 1, and it's going to have 1 milliliter added to it. And then solution number 2 will have 2, 1, 2, and then solution number 3 has 3 in it. 1, 2, 3, and then we need to put 4 milliliters into our last one. 1, 2, 3, and 4. Now, if you look very closely at these, you can see that they are all 5 milliliters. Okay. Now, let's see how you can tell. So so let's look at these. You can see, hopefully, you can see that we get progressively darker in color as we go from least concentrated to most concentrated. Okay, let me go ahead and show them like this, and hopefully you can see that as well. Okay, so now we're going to come back over here to our lab quest, and oh, I just realized that I didn't completely set this up very well yet. There we go. Okay, and now it's showing absorbance, which is what we're going to be looking at here. And I need to change my mode to events with entry. Okay, and let's see, I'll have absorbance on my y-axis and concentration, C-O-N-C for concentration, and units, we're going to go ahead and make that a capital M for molarity. Okay, so this is actually just called a colorimeter. If you were working in a different kind of a lab, like with, you know, better technology, this would probably be called an absorbance spectrometer or spectrophotometer. Okay, but for here, they're just calling it a colorimeter, that it measures how much color or pigment we have in something. Okay, and what we're going to be using is this piece of equipment here. Let me see if I can get a good view of it. This is called a cuvette. C-U-V-E-T-T-E, cuvette. You don't need to know how to spell that, but this is called a cuvette. And look, on this side, the sides are smooth and you can see straight through it. And that's the side that the light is going to pass through. And then on this side, you can see that the side is serrated or almost prismatic. And that's so that you can get a good hold on this side, the serrated or prismatic side, because it's textured, and then not put any fingerprints on this side. Okay, so now what we're going to do, and I apologize for my poor video skills, but we are going to begin with, and I'm actually going to rinse this out real well so that we don't have anything in it. Okay, and then what we're going to do is we're going to always begin with a 0 point. So I'm going to use the disposable pipette here to fill this. There we go. Okay. And then we'll bring it over to here, and I'm very carefully going to put it in like this so that it goes through, and close it. And then I'm going to come over here and we'll choose begin, and it's telling me that I have nothing being absorbed, which is perfect because it's pure water. So this will be a 0. Okay, so now we'll take this out. Okay, and now I'm actually going to just put this into my waste container here. All right, and so now what I'm going to do though is I'm going to fill this, hopefully without making a mess, with my solutions. Okay, and there is solution number 1, which we are calling 2 molar. And I'm going to very carefully pop that in there and close it and come over here where I can see my absorbance. Okay, and then I choose keep, and I'll put in a 2 for that. Okay. And now, since I don't have any extra and I want to be real careful just in case, we'll go ahead and dump that out, and then we'll go on to our next one. If anybody's wondering what I'm using here, I'm actually just using food coloring. I can't remember if I said that in the lab. You can do it with any liquid solution that has color, that is not colorless. Okay. And I'm putting in 4 for that one. And just like we did with the last lab, we will we'll get all the data at the end. And now here is solution 3, the one that we're calling 6 molar. So you might wonder, you know, why are we just calling it that? Well, since we are in my house, whoops, sorry about that. Since we are in my house right now because there aren't any labs going on, we want to make sure that everything, you know, I don't want to use chemicals for no reason, whether in my house or in the lab. And this is safe. But if you were working on an experiment that required a solution that had a natural pigment to it, then this would be a good way of determining your concentration. Okay. And then last but not least, here I am with our 4th solution. Making a little bit of a mess here. So I have the paper towel. Okay. Again, sorry for my poor video skills. Okay, and here is, oops, sorry. Okay, we've settled out. And there's our 8 molar. And you can see, hopefully, that we're getting a really nice straight line here, which is excellent. That means that I did a good job of making my solutions. You always go from the least concentrated to the most concentrated when you're doing this. And now I'm going, just like I got a perfect 0, I'm also going to use my pure stock solution, which again is just about, I think I had like 75 milliliters of water and 2 drops of food coloring is how I made that stock solution. Okay. All right, and it appears to have settled. So we'll call that 10. Okay. Now I'm going to go ahead and stop this, okay, so that I have that, and I'm going to come out to the front here. And the reason for that is because now what we're going to do is we're going to get an unknown. Okay. Now, hopefully you've already done lab 3 at this point. If you haven't, that's fine, but attached in lab 3 is a tutorial for how to plot these in Excel or Google Sheets, and you'll need to do that again with this lab. Okay. So what I'm doing before I get these values is I'm going to go ahead and just come over to the second page and take a solution of unknown concentration and find the absorbance of it. All right. Well, you know what I'm going to do? I'm going to make an unknown right here. Let's see what happens if, and I'm going to turn this so that I can't see any values, and I'm just going to pour in some water, and I'm going to pour in some stock. Now, I can swirl it around and I can say, oh, I wonder what I made. Well, I can use this method and the value that you guys are going to get to determine what the concentration is of the solution that I just mixed. Okay, so I'll come over here and place it into there. And I see this settling at right around 0.545. So we'll come over here, and right here you're going to write absorbance equals 0.545. Okay, and now let's go ahead and write down our recordings from our values here. Okay, so you'll see that on here we have concentration, transmittance, and absorbance. And transmittance is almost like the opposite of absorbance. It sort of makes sense. How much light are you transmitting versus how much, versus how much light are you blocking? Okay, so now in here I can see, I'll come over here, and under my 0 molarity, that was just water. Okay, so this was just water. Okay, that had a 0.000 absorbance, and I'm going to keep all my significant figures. And then I can see in my that for 2 molar I have 0.250, and for 4 I have 0.453, and for 6 I have 0.621, and for 8 I have 0.773, and for 10 we have 0.907. Okay? All right, now all you're going to do is you're going to take these values. Concentration is on your x-axis, absorbance is on your y-axis. You're going to use Excel or Google Sheets to plot this data. You're going to use just like before in lab 3, you're going to use a scatter plot. Okay, and then make sure that you use the trend line tool to determine the linear equation. And your linear equation is in the form here of y is equal to mx plus b. Okay? Absorbance is your y value. So up here, you have a y value. This will be y. Okay? And then down here, you need to use this equation that you get from either Excel or Google Sheets or some other Google Sheets. You don't have to use these 2 programs. You can use any graphing program that gets you a trend line. I just want to see the graph and the trend line. Okay, and you're going to write that y equal to mx plus b, Okay? But in order to determine the concentration, you're solving for X in here, which here is the formula that you will use to solve for concentration. Let me know if you have any questions.